Hi, I am Umar Javed from CyberPanel. In this video, we will discuss Tracepath and Traceroute. So what is Traceroute? It is a network diagnostics tool that maps a route through which packets travel from the source of the pack, such as your computer, to the destination, such as a web server, by sending packets into the network with TTL values that are incremented. Every router that forwards the packet decreases the value of TTL by 1 until TTL has reached 0 when an ICMP time exceeded message is sent back containing the address of the router and the round trip time for the hop. This is continued until the destination is reached and the maximum limit of hops is exceeded, whereas tracepath is often found within modern Linux distributions. Tracepath also traces the path that take through a network except for the fact that it measures the path MTU. This ability to measure path MTU aids us in discovering the maximum usable packet size that can pass without fragments, which is important for troubleshooting performance-related issues asking for such big packets. There are several misconceptions about these tools that may confuse the process or lead to ineffective troubleshooting. Same with confusion between Tracepath and Traceroute, which means they are two tools that function identically well and with no significant difference. Although they are similar in concept, their functions are notably different. While Traceroute primarily focuses on tracing the path of packets through the network, Tracepath provides additional information about the MTU along the path that can prove essential for diagnosing certain types of connectivity problems. There do exist differences in output formats also. A typical tracepath will list hops and RTT numbers for each, while a tracepath uses MTU information to help provide network audience see more of the path. Another misconception is that Traceroute is therefore in fact more accurate than Tracepath. While widely regarded, Traceroute relies on the different set of factors, including network configuration and router tolerances to dictate randomness in accuracy. Inhibitions introduced by router and firewall configurations that filter ICMP packets will bias the results offered by Traceroute. Where the router does not respond to ICMP packets, user will see the route blocked or malfunctioning. By reporting the MTU, Tracepath can provide a more insightful knowledge of possible problems than Traceroute will, particularly involving problems that may be caused by packet fragmentations. Hence, in instances where packet size is of concern, Tracepath may prove to be a tad more resourceful. Though one might bemoan and definitely be right about a predominance of Tracepath in Linux environments, the belief that Tracepath is a tool specific for Linux is wrong. There is, as stated, neither a Windows nor a Mac operating system native tool. Still, there are tools and ways by which one can obtain similar functionality. Windows users have path ping, which blends features of ping and traceroute. Mac operating system users have to use Traceroute directly from the terminal and won't have direct access to Tracepath. Some users confuse Traceroute and Tracepath as simply diagnostic tools for connectivity problems. These tools are indeed effective for this purpose, but distinctly factor into a wider variety of niche uses. This is an aside, as both tools could also be applied for performance analysis. Employing per hop RTT inspections might help network engineers diagnose exactly where latencies take place and go about troubleshooting given circumstances. The generated output of the tools assist in the making of a mapped network topology, which in a way directs towards the network structure and possibly fringe points. Another assumption is that running Tracepath and Traceroute will provide the same results. Although they can be similar pathways, outcomes may be different due to the network routes may change due to multiple reasons like load balancing on the network, dynamic routing, etc. Because the two tools may be reporting different state at different points in time, this can lead to the two tools reporting different paths. Traceroute may utilize ICMP or UDP packets and Tracepath commonly utilize UDP, so the responses may vary depending on how routers treat these various kinds of packets. Traceroute is a very useful tool, but it is not always the best tool for the job. Depending on what sort of problem you have, one tool is better than another. If you think the issue is because of packet sizes or fragmentation, Tracepath is better because it can discover MTU. If you just want to find out the path to a destination and don't care about MTU, Traceroute is just fine. The results from these two tools are thought to be correct by some users. However, due to some variables, these results may not be that reliable. A slow RTT due to high congestion can affect the performance and give you false results. Different packets might not get the same response depending on how they are prioritized at the router level. Though these are often used by network administrators, they are not limited to that audience. The Tracepath and Traceroute tools are advised to anyone who really wants to know how a network is behaving. Software developers and IT professionals frequently have to deal with network-related problems and use these tools for troubleshooting. If these are not too technical users, they still can use these tools to better understand the correction issues they face, slow loading of the website, etc. Many users run these commands without fully understanding or analyzing the output, although the commands are simply initiated. The right deduction of the information out of it is vital for this process. Realizing how to decipher RTT values will help to find out possible traffic jam in the network. Timings in the output sometimes may cause a case when the router is not responding or is being blocked, which needs to be investigated. Some believe that with the advent of more sophisticated network monitoring tools, traditional tools like Tracepath and Traceroute have become obsolete. Although new tools are much more advanced, let's not forget about Tracepath and Traceroute, which have stood as the basics of network diagnostics. Their way of being so simple can make them useful and easy to use in a matter of seconds, especially if more elaborate specialized tools are not on hand. Currently, it is not uncommon for really efficient network monitoring solutions to include Tracepath and Traceroute diagnosis tools, therefore giving them a place in the company's arsenal of tools. Tracepath and Traceroute are incredibly useful in the realm of network diagnostics. Nevertheless, misconceptions about their functionality can result in ineffective troubleshooting. Through a proper understanding of the differences between these tools, their specific uses, and the way to read their outputs, the network professionals will be able to make the correct decisions that will contribute to the network management. Thank you for watching this video and subscribe for more videos.